Hello,
All right.
thanks everyone for
Hi.
joining. My name is Evan Wimpey. I'm a director at PyMC Labs, and I'm a volunteer with Informs, where I host Insights, which is a fantastic opportunity to talk to people who are involved in the Informs community and the analytics world writ large. Today, I'm very excited to talk to our guest, Melanie Barker, who's a senior simulation consultant with Rockwell Automation. Melanie, thanks so much for joining Informs Insights today.
Yeah, you're welcome. Nice to meet you.
Good to meet you as well. To start off, maybe we've got a lot we want to dig into today, but Melanie, to start off, can you give us just a quick, maybe a little more than elevator introduction, maybe like a cocktail party introduction, just on who you are and what it is that you're doing today with Rockwell Automation?
Sure. Yeah. Hi. My name is Melanie Barker. I am an industrial engineer by background. So I'm a Florida native. I went to the University of Florida, and after I graduated, I went to work for Walt Disney World as a labor maintenance analyst at the Studios Park. So the idea with that was taking previous historical data on attendance, doing work studies, putting those together, and coming up with forecasting of labor needs. So that taking a more analytically based approach to how to schedule labor in the theme parks. From there, I went to support what was at the time called Downtown Disney, is today called Disney Springs, the retail dining entertainment district at Walt Disney World. And I was their industrial engineer. So just various, capacity studies, any kind of things that they needed from an industrial engineering perspective. And after that, I went to go support the transportation group. So we were looking at implementing a major project in using demand and making a more flexible schedule for buses of how the buses were going to serve that demand. Um, During that time with the industrial engineering department, I had started working simulation had been one of my tools in the toolkit, like many industrial engineers, and I had always really enjoyed doing simulation projects. So I had looked into specializing more in simulation and ended up then getting a job with Rockwell Automation, who makes the arena simulation product that I had actually learned on the job at Walt Disney World. And so doing simulations full time. And that's what I do today. So today my role is as a simulation consultant working with Arena. And I build turnkey models for our clients that don't have the in-house resources or just don't have the time to do their own model building. So I'll go and act more as a traditional consultant in those engagements, understand their system, create the simulation model, turn that simulation model over to them, teach them how to run the model and analyze the results. I also work with our clients who are building their own simulation models, whether that's we have a formal training class that I teach, take them through that. We also have this opportunity for one-on-one consulting hours. And so that's just me getting together with one of our users and them saying, hey, here's the system I'm trying to simulate. It might be something like, how do you recommend approaching this? How do you recommend breaking this down? Or what are the pitfalls? What are the things I should be aware of? Sort of just helping warn somebody about the things that I have learned over the years in my simulation projects of helping them be more successful faster. So
Awesome.
that was
Yeah.
me in a long elevator speech.
Yeah, we're right into the very top floor.
Yep.
Melody, that's great. We're gonna dive into to Rockwell and the simulation focus. I think probably also with a primer on sort of what simulation is for the analytics background, less industrial engineering or OR background. But I do want to rewind a little bit and get into the Disney world. Maybe because Disney is just so magical, as they say.
Yes. Yes. Everybody
But
always loves it. Yeah.
Of course, of course. And you're in Florida now, so you didn't get too far away,
Yeah.
even after you left. Yeah, it sounded like you had a number of roles there from labor into transportation and sort of general planning. Can you talk about some of the decisions that you were helping folks to make? I think when we talk about analytics, sort of the the key thing people want is how can you drive better decisions? What type of decisions are people supported because of the analytics you're doing? So I think
Mhm.
Disney is a pretty tangible thing to
Yeah.
think about. People are familiar with the parks, even if they're not Disney people. So I think it would be interesting to know sort of what decisions you were helping Disney be able to make.
Yeah. So in the first role, like I mentioned, that was putting together attendance forecasts um, with labor work standards that I would go out and conduct. Before they had basically just scheduled the same number of people for a day that they had scheduled the previous year. So they weren't really able to be analytical about how many people they would schedule. And this was taking a more analytical based approach of if we're now expecting a higher attendance on this day than we had gotten the previous year because of some new event or something. Now you can be more responsive to that, or vice versa as well. Don't overschedule if you're not going to have as many people as you expected. Not that that ever seems to be a thing at Disney anymore. Um, so yeah, that was the first role, and I enjoyed it. It was a good way to kind of get my feet wet, but it was very repetitive after a while. It was, do the same kind of work study, do the same analytics, and it was really sort of rinse and repeat. Same thing over and over again. So I did that for a couple of years, and then I went to my manager and said, "Hey, I'm ready to do something a little more varied." So talked to him. That's when I went and interviewed with the industrial engineering department, which is a separate department at Walt Disney World, and got transferred into that group. And like I said, went to the Downtown Disney, now Disney Springs group. One of the big projects that I worked on that we would do every year there was what we called a summer study. And we would literally station data collectors at every single entry point and exit point. We would have somebody going around the parking lots, counting how many cars were in the parking lots. And the whole purpose of this was it was 4 days to try and understand what did attendance look like at Downtown Disney? What were their peaks? What did that just like, how did that, um, look over the day? And the funny thing about a lot of the work that I did then and did at Disney earlier is you would not do it today because you have the data.
Sure.
The amount of data that they now have has changed dramatically. Like when I started as a labor maintenance analyst, I remember somebody introducing me to the merchandise data warehouse, and they were so excited because you could sit at your desk and get a whole day's worth of data. You didn't have
Wow.
to go out to the parks anymore with a floppy drive and put it into the point of sale system, download the data, and bring it back to your desk. That's what people had been doing, within like a year or two of when I started. Um,
Wow.
Now you could just query this database, but don't query more than one day at a time because that took forever. So one day at a time, and then download that data, and you could use it for all kinds of analytics.
Oh my gosh. Yeah,
I know.
compared to today, where the smart devices in a single family home, you get more data than that across your property.
Yeah, yeah. I mean, today Downtown Disney has Disney Springs has these giant parking garages, and you're counting the cars in and out. You don't need to send a data collector around anymore to physically count the number of cars in the parking lots. They have stations where the entry and exit points are now more controlled for safety reasons and security reasons. So now you know how many people are coming in. You know when they're coming in. So it's kind of amazing to me when I do go and visit the parks and Disney Springs these days to just look at those things and realize that the work I did isn't done the same way. I mean, what must they be able to do nowadays with the amount of
Sure.
data that they now have? I mean, you've gone from famine to feast and maybe
Huh.
even beyond feast, whatever that level is.
Yeah. Gluttony.
Yes, yes, I
Too
like that.
much data.
Famine to gluttony. Yes.
Awesome. Melody, yeah, a few things that I would love to follow up on there, but one of the things that you mentioned, a lot of the insights listeners are early career professionals, and dare I say, some folks might resonate when they say their first job that they get in the analytics world, they work it for a little while and then tend to get bored. And
Yep.
so the idea of going to a manager and saying, "Hey, I'm bored, I want to do something else," it maybe can be a bit of an intimidating thing, especially for someone early career. So can you talk a little bit about the steps that you took to do that, the relationship that you had with your manager, and sort of how that was received in a successful way?
Sure. Yeah. My manager had also been in the industrial engineering department, so they were familiar with the studies that I was doing. I don't think it was a shock to them that this was something that was probably only going to hold somebody for a year or two. So that definitely helps. Like if you're working with somebody who's got some reasonable expectations. And I think the big thing too is when I went into him, I didn't go in and say, "Hey, I'm bored. I want to do something different." I positioned it more as, "Hey, I'm ready to take on some new work. And what we're doing, I feel like I've tried to improve and optimize and make these processes as repeatable as possible. But I feel like I've kind of done the best I can do with this, and I'm ready to move on to some new opportunities." Um, They actually, I had started as the single labor analyst. They ended up bringing two people in. So I'd love to tell everybody I got replaced by two people. Well, and part of it was, when I was first getting started, we only did a few of the locations. And as I think those locations saw success with using this approach to how they were scheduling their labor, and this isn't just on me, there was a whole, group of us across the property. I think a lot of it too was just this was, the late 90s, early aughts. People were becoming more accustomed to this idea of we're going to use analytics to make decisions that before we've sort of gone off of just gut feel and how we've done things before. And this idea of no, we're going to change the way we did things before, and we're going to try these new ways of using the data we have to figure these things out was really still kind of a new thing there. And so I think just cross properties that begot as that became more, people became more open to that. It was easier to bring more people in and start doing more locations. So yeah, um, so that was a big part of that conversation was again just going in and making sure that it didn't sound like I was being whiny, that it was more about I'm ready to grow.
Yeah, fantastic. Frame it positively,
Hmm.
and I think a good manager will look for those opportunities to for somebody who is ready and able to take on more, which is great.
Yeah. And I think it also helped I'd had success in the role. Like I had been doing well, I'd been getting good evaluations. I think that conversation goes very, very differently if you have not been doing well in a role. And I also want to say there's no shame in that. I mean, I struggled when I moved over to the industrial engineering department because it was all of a sudden a lot of new projects. Like it wasn't that rinse and repeat of the projects that I had been doing in the maintenance analyst role. And so I absolutely struggled. I would say the first year or two that I was in the industrial engineering role until I kind of found my feet and was able to do better at that.
Well, yeah, that's interesting, and it's great, that the management and the team trusted you. You'd had success in the previous role, and you're able to grow and obviously be successful and move on and stick with Disney for a little while. Um, Melanie, you mentioned that you actually were familiar with the arena simulation software at Disney before you went to Rockwell. Can you talk about the use case for simulation, sort of what got you into it? I'm sure there's lots of
Mhm.
use cases in the industrial engineering world, but sort of where your exposure to simulation in practice came.
Yeah, so actually, probably the most fun story I have for how I use simulation at Walt Disney World was the monorail. Um, if you remember, if you visited Disney, and probably I think this was around the mid aughts, the monorails used to have these sort of flexible seating in the middle of each cab. And the idea was in the shoulder periods, you would go up and you would unlock this bench sheet and you would put it down. So you'd add more seating. Yeah, that never happened. So you ended up just having this thing in the middle of the open space that was taking up space. And so we came up with it had been asked through the transportation group, like, what if we took this thing out? Could we do that? Is it worth doing? And so what happened is it actually ended up being this very multifunctional team. So it was me from transportation as their industrial engineer. We had the industrial engineer from the maintenance group. We had some other folks from maintenance from Ride and Show who were there to evaluate, can the monorail actually, like, is that thing structural? I mean, is it safe to take that out, when the monorail moves around? And so, started there, obviously, like, let's not even consider this if it's not going to be safe to do that. So they determined, yes, it would be safe. You could take that out. Then the industrial engineer from the maintenance group and I worked together on creating a simulation of if this is the current operation, we increase the capacity of this particular resource as it's moving along, and what does that do to the wait times? And so we ran into this problem of we didn't know what the wait times were because again, lack of data. And at the time, what they would do is it's called blowing the gates, when the wheelchair gates are just opened. And so everybody just streams out. And not everybody who's leaving is going through a turnstile. So you have no
Ah,
idea what that exit pattern actually looks like. Now, again, today, this is probably a problem they don't have anymore. So what we had to do, we did have the graph of, we kind of trusted like this is probably what it looks like. We just don't know what the volume would be in terms of what that demand looks like, what the overall, numbers are. So what we did is we just kind of went to everybody and said, okay, what's your gut feel like? What do you feel like the average wait time is at peak? And so got that feedback, and we then tuned our simulation model using that curve as the curve of how people arrived. We tuned it demand wise, and so we got to that wait time that everyone felt like it was. Said, okay, this is our current state. We're all in agreement. Now let's increase the capacity of the monorail and see what happens. It took, I want to say we agreed that it was probably about a 30-minute wait time. It took it down to like 9 minutes. And it was to the point that the maintenance IE and I were sitting there going, nobody's going to believe us if we report this. They're going to look at us and go, that can't be right. We knew we'd probably just get dismissed out of hand. So we ended up just being super, super conservative. I want to say we took like the 85th percentile or 90th percentile wait time and said, okay, we think we're going to get at least below this. And so that was enough to certainly say, yes, this is definitely something we should consider. So they took one monorail, took out the middle poles, and put it on the beam one night. And so we did a study that night with that one particular monorail in operation to see realistically how did that work. By the end of the evening, the cast members had started nicknaming that one particular monorail the sponge because they could feel the difference in, I mean, and it wasn't that much of an increase in capacity. I want to say like maybe 1.5 people per like cab area,
Wow.
but it was just enough that it kept you from getting as overwhelmed as they had been getting previously. And so, yeah, I mean, the simulation justified it, the actual experience justified it, and so now if you go ride a monorail, there's no little seat there area in the middle anymore.
Oh my goodness, that is a very cool story. And
Yeah.
yeah, I think a very cool technical story, like map your simulation to meet what people are expecting and sort of the qualitative, here's what we think the wait times generally are. But I think really a great story in communication, because ultimately, if you're trying to drive the decision of, look, we know the right decision is to remove the seat or at least experiment with removing the seat, how can we best do that? And it's not report the mean or average or whatever it is that sounds so unbelievable. You can report something more believable that still is true to your analytics, that is still
Mhm.
driving the decision from the people that need to buy the analytics.
Yeah, there was definitely a lot of psychology in that project, not just numbers.
Ah, yeah, very interesting. Is it's been too long since I've been to Disney. Do you know if the monorail is still there and there's no seat, there's additional capacity?
Oh yeah, it's I'm trying to remember the last time I wrote it. It's been a few years, I think, as well. But I noticed the other day on Disney Plus, they now have a video where you can watch the monorail for 4 hours. They've just put a camera in the middle of it facing the doors, and you can just watch this for 4 hours if you like.
All right. All
I
right. I
did
I can
not see any
imagine.
additional seats, so
Good. And it's fun to click in there, I bet, and be able to see, look, that's a tangible impact that your
mhm.
analysis had. Oh,
Yep,
great. So that's foray into simulation. And I want to talk next about your transition. Then you found a niche, you found a specialty, something that you enjoyed or excelled or saw opportunities. But before we do that, thinking about your career, I think it's probably it's common to hear machine learning and predictive analytics and predictive modeling and of course AI, but simulation is maybe a bit lesser known. Can you
mhm.
briefly just describe sort of to an early career analytics professional that might have heard it and well, it sounds like are we just making up data? But maybe what exactly is simulation and sort of what's the use case for it
Sure,
generally
yeah.
rather than just the specific example there.
Well, and simulation can be a very wide bucket of things. Like, are you doing physics simulations, or what kind? Are you doing heat simulations? What exactly do you mean when you say simulation? So, when I talk about arena and simulation, we're doing discrete event simulation. So, I almost explained it as like it has a task list, and it's going to work through its task list, and that those tasks are going to be the events. So, the event might be somebody arrives at a certain time, they start, they grab a cashier, they begin a transaction with that cashier, they end the transaction with that cashier, and then they depart. The key thing is that there's a calendar. And so the simulation has its calendar, its task list, the tasks happen at certain times, and it doesn't simulate the time in between when there's nothing going on. So it jumps ahead from time to time to time. And the three areas, and as you can imagine, one of the things we do with clients is we do help them understand not just when a system is a good fit for simulation, but when it's not a good fit for simulation. Um, and so one of the things that we try to emphasize to people is there's really three things when it comes to our type of simulation that we are looking for. Number one is going to be variability. So variability in your arrival rates and your processing times, failure rates, any kind of variability that you can describe. So it's stochastic, you can describe it, but it's not deterministic. We don't know exactly when that next person is going to arrive. We don't know exactly how long that transaction or that processing is going to take. We don't know exactly when that machine is going to go down. Number two is then going to be resource constraints. So, again, you've got cashiers, you maybe got two, three of them, you have a capacity constraint around there. You've got equipment, maybe you can only put one part on it at a time. You've got storage space, but some kind of capacity constraint such that that is limiting how your system functions. And then the third is a little fuzzier. That's really more a time-based system interaction. Um, the example I always like to give people for that one is you go to the grocery store, and let's say you're running the grocery store and you're trying to figure out when should I open that extra lane? So if you're looking out at the number of people in each lane and you say, okay, there's four people in each lane right now. Should I wait until there's five? Should I open it when there's four? Should I do it when there's three? With a simulation, that's a really, really easy question to analyze because you can look at what happens when I do it when there's three, because your simulation has the ability to model that time and that current state of the system and make changes based on that current state of the system. There's actually an example model we use when people have not done simulation before, where we take a system and some deterministic processing times and we say, hey, you could plug this into a spreadsheet and determine what the throughput would be of the system. You've got three machines, you're operating in serial, so a part goes from machine one to machine two to machine three. Now, what happens if it turns out those times aren't really exact? They're averages, these times are maybe actually exponentially distributed. Then what does the throughput of our system do? And we show how, oh, actually it's still the same. It's roughly the same. A little bit of variability in the output now, but not really much has changed. We then go back and say, well, okay, what if we had deterministic times, but we now have this system interaction of we have our capacity constraint. Each machine can only, work on one thing at a time. And we also have this constraint of you can't have any work in progress between the different machines. So in order to let go of machine one, the part must be able to go into machine two. Machine two must be available. How does that affect things? Well, when you've got deterministic times, it's the same. It's no big deal. When you put the variability and the interaction of you can't have work in progress together, you all of a sudden lose 25% of your throughput. Because what happens is we purposely make machine two our bottleneck. And when you have variability in the processing times, and now you have a long processing time on machine one, all of a sudden, machine two has no queue that it can pull from because there's no work in progress allowed. So now you are starving your bottleneck. And that's something that we show, very, very quickly in a simulation, how you can see that and see that hit to throughput. And that's something that your spreadsheet isn't going to tell you that. And it would be very difficult to set up your spreadsheet because that time basis is really important to understand what's happening in that system.
That's a great example, and you can already think sort of across industry use cases, sort of what that
Mm-hmm.
maps to in the actual real world. And I'm thinking of queuing lines because that was your
Yep.
example in Disney, but yeah, you think so many industrial use cases. Awesome. That's a great primer, and you can see you're excited about simulation. And so I want to talk about the transition when you first made the jump to Rockwell. This was something. Can you talk about sort of what your career experience had been like thinking about simulation, and what was it that made you want to make the jump into simulation sort of directly, and
Mm-hmm.
what brought you to Rockwell?
Yeah, so I had taken simulation in my undergrad course. The package I used at the time was GPSS, which is a Fortran-based text simulation program. Yeah, that always makes me feel a little old. But so, like I said, learned Arena on the job at Disney, and just really appreciated kind of the power of this analytical tool. I actually like I think I had mentioned earlier, I wanted to specialize more in it while I was still at Disney. But the funny thing is the industrial engineering department at the time actually kind of had to push back on, so we functioned as an internal consulting group to our clients. The industrial engineering department actually had to push back a little bit on clients who wanted simulations because there were other analytical tools that might have been easier, faster, just as appropriate. But as you can imagine, Disney people love seeing little things moving around on the screen, little animations, which a simulation will let you do. And so it it wasn't that we didn't do simulations, but they tried to sort of make sure they were only doing them when it was really, really appropriate. And there just wasn't enough work at that time for me to be dedicated to it. So that was one of the reasons why I looked into doing this full time. And one of the things I've actually really come to appreciate in my current role is, so I've worked for Rockwell for almost 16 years now. That whole time as an arena simulation consultant. So as you can imagine, I have deep, deep knowledge of arena at this point and how to apply it to various systems. But because I'm constantly working with different clients and different projects, I get a lot of variety through, today I'm doing a system where we're cleaning out 5-gallon water bottles like you have in your office and filling them and returning them to usage. I've done simulations of an ice cream manufacturing facility. I've done work in oil and gas. I've done healthcare. I get to get a lot of variety while still being able to have that deep mastery of the subject. And that's a really hard thing to find where you can kind of have both. I get to be really good at something, but I get variety.
Yeah, I think especially thinking for someone sort of early career where, if I pick something, if I'm a labor analyst, then that's all I'll get is I'll just be doing labor analysis in this sort of small world, no pun intended, for for a career, but being able to build the expertise, but still have the breadth. I think that feels like a great sort of career path
Mhm.
to get yourself into and to be able to find the thing that where is it that you want that expertise? What
Yeah.
how do you find the thing that speaks to you that you
Mhm.
enjoy so much?
Well, and I would
Um,
also add to that, one of the reasons that I did end up leaving was going back to that whole data, famine to gluttony. I think because of not having as much data then, the there's a lot of people in analytics at Disney today, a lot more than were there. And I think they're much more analytics focused than they were at the time that I was there. I think that was growing while I was there, but it wasn't really, I didn't feel like there was really a technical career path at the time. And a lot of it was if you want to continue growing in your career, you're going to have to go into management. You're going to have to, move up the corporate ladder. And that wasn't what I wanted. I wanted to stay technical. I wanted to continue being an industrial engineer. I'm still an individual contributor. I have never managed anybody in my, oh gosh, how many years of career now? Nearly 30-year career. I've never been a manager because I like solving the problems. I want to work on the models. That's what excites me. And so that was one of the major reasons that I left. Now, it's funny because today I don't think I would have to make that decision if I were still working at Disney, but that's what the situation was at the time. So that's one of the other reasons why I left and went more specifically into simulation.
Great. It sounds like a very healthy career development choice there. Melanie, just a few more questions I'd like to ask you. One is for folks that are hearing about simulation and learning about sort of example use cases for the first time or the first time since, one lecture in undergrad. Do you have any tips on where you could go to practice those skills or skills that would be particularly important or use cases to look out for? You mentioned sort of the questions that you ask if
Mhm.
simulation would be a good case, but maybe you've got a case. How do we get started into simulation?
Sure. Yeah, I would say a couple things. First are pitfalls to look out for. So you want to make sure you're not trying to solve an optimization problem with simulation. We had a student contact us once who was she had a list of 11 things that she needed to produce, and she wanted to use a simulation and enumerate every single possible combination or permutation of how you could produce those 11 things and simulate them. No, 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 no. Don't do that. You're like, hey, let's explain. There's this thing called traveling salesman. You have just found it. So yeah, that's not a good fit for simulation. Um, so one of the things we try to do is educate people on when you're trying to do an optimization problem, and there are better techniques, heuristics, et cetera, for that. So the other big thing I would say with simulation is the hardest part is almost never going to be building the simulation in whatever package you end up using, Arena, et cetera. The hardest part, for me at least, and I think for most people, is going to be going into this potentially chaotic system, this real world operation, and you have to find a way to describe this system in blocks that you can then move into a simulation. You have to sort of find the patterns in the system. And one of my now retired coworkers always used to say, you can't model chaos. There have to be decision rules around how things get done. You can't just have this person's working today, so this is how we pick which thing we're going to work on next. Oh, this person's working today, so this is now how we're going to pick things. It has to be what is it? Is it due date? Are you trying to minimize changeover? You have to have some sort of rules around how you're operating this. And that's not just for the simulation. I mean, you have to have this in the real world too. But that's something I would always tell people when they get sort of into the weeds and bogged down of, well, how do I make this decision? I'd say, well, go back to your operation. How do you do it? How do you actually make this decision? And sometimes people can't answer that. And sometimes we've had a couple of simulation projects where we started creating a specification and ended up not building a simulation model because the act of creating that specification brought up organizational issues that were not going to get solved with simulation, issues that had to really be resolved before it was even worth trying to do some analytics. And some of that was bringing the people together to figure out how you're going to do this. Actually, one project I had that's probably a good example of this is a greenfield food and beverage manufacturing, and it was a company that had been outsourcing this particular product that they produced under their label and decided to build a factory and produce it themselves. So they had never done this before. They had done some aspects of this, but the full manufacturing was something that was new to them. They brought in a lot of people from other companies that had experience, and they were designing this. And then they basically wanted a simulation to kind of prove that it was going to work before they built the facility. So they brought me in for that. And my manager came with me for these specification sessions. And I will never forget sitting in this boardroom. And on one side of the table, we had operations. And on the other side of the table, we had the research and development folks. And the research and development folks would describe, oh, this is how this part of the process is going to work. And the operations people just looked at them and said, no, that is never going to work in the real world. And then they would sit there and argue. And so my manager and I just kind of sat there like it was a tennis match, watching them go back and forth. But it got them to actually sit in a room together and discuss these real tactical details of how are we going to do this? How is this actually going to work on a day-to-day basis? They came to an agreement. We wrote it down, and that's what we built in the model.
Wow. Yeah,
Yeah,
that's by even asking the questions to simulate to build the simulation model, you sort of align on what needs to happen in the
yeah.
real world. Yeah.
And it's funny how many times simulation projects do that, that you're, because a lot of times people that, especially if they're in the operation, you're trying to just get the operation done day to day. You don't always have that opportunity to take a step back and say,
Yeah.
why do we do this? One of the other places that we went to where we ended up not building a simulation model, I think that's really what had happened is they had started as a very small company. And, this was a company that was nearly 100 years old at this point. And I think they had just grown. And each time they grew a little bit, they bolted on what they needed to bolt on to support the current demand and volume. But they got to this Frankenstein point at the end where it's never the way you would have operated a system that had this level of volume, but it's where they had gotten to. And so I think as part of starting again doing that specification, they kind of realized, oh, we've got some internal like siloed departments that we have to get talking to each other and figuring these things out before it's even going to be of value to try and build a simulation.
Yeah. That's great. The zoom out, the broad world view. That's great. Melanie, I do want to ask you one last question at Informs. The tagline, of course, is smarter decisions for a better world. You're out there consulting a number of different places, helping people to make smarter decisions. Do you have a favorite memory or a favorite decision that people are trying to make where you feel like this is doing your part to help advance that tagline, the smarter decisions for a better world?
Sure. Yeah, I will say this is a somewhat older simulation project I worked on, but definitely I think one of the most impactful. Um, it was of a healthcare facility where they were doing drug trials for cancer patients, and they were doing level one. So this is not where these were basically patients who were terminal, for whom the traditional methods had not worked, and these patients were coming and having these trials done. These were just safety trials; they weren't even efficacy. And the idea was, these were people who knew that they were not going to survive their cancer, but they were at least going to go try this experimental drug, partially as why not, and partially as, at least maybe they can help other people. So the wonderful news is these drugs were working. They were keeping these people alive. And so these patients were surviving for much longer than had originally been expected, which was great, but that meant they were continuing to bring new patients in and test new drugs. And so the demand levels of patients that they had was continually increasing in a way that they had not been prepared for. Um, they had nurses who were staying there till, 6, 7 o'clock at night, like hours after, trying to give all these people their infusions and their medications and make sure that they got their treatments. So you have all these patients who were terminal who were spending just hours in this facility, wasting their time waiting. And so they brought us in to do a simulation model because they wanted to test a few different things of, what if we bring these patients in earlier, the patients with more variability, but what if we bring them in earlier in the morning so we're prepared to handle that when it happens? What if we rearrange the process a little bit and do this particular step more in parallel? How will that affect things? And as you can imagine, they didn't want to do this in the real operation and affect these genuine patients who are already going through enough. So they wanted to use the simulation model first to kind of test out these ideas, and the simulation model showed them that, yeah, great, gave them the thumbs up. They implemented it in the real world. And I can't remember the numbers off the top of my head, but they saved, I want to say it was well over an hour on average for a lot of those. It was around an hour. It was either like 45 minutes or, 75 minutes on average per patient in that facility. So that's real time. Those patients got to not be sitting in a waiting room waiting, and got to enjoy the time they had with their families.
Oh my gosh. Wow. Yes, better world indeed. Yeah, that's a very tangible result of the benefits of the decisions that you're helping to drive. Melanie Barker, our guest today on Informs Insights. Melanie, thanks so much for joining. This has been fantastic. Is there a place where folks can follow you, the work that you're doing, anything that you'd like to point them to?
I mean, I am on LinkedIn and I've been on there long enough that I believe I am, I got my own name as the extension.
Perfect. Melanie, thanks so much for joining us today.
Thank you.